Okay, so this here, acid rain. Look here, I said CO2 in the air, right? Dissolves in water to form carbonic acid. This is the same thing with this acid water, right? So acid rain, same thing. You can call this carbonic acid. Same thing. Since it's acidic, it can dissolve the rocks. And it frees up this, all these minerals. They get washed up with groundwater into the oceans and forms calcium carbonates in the ocean. What are these calcium carbonates used for in the ocean? Look over here. What did I write? Shells. Right? You're asking me about this. Shells. When this gets into the ocean, all of those animals that need shells for protection, like crabs, any of those animals underwater that need shells, they use this to build their shells. Even corals, right? So in the ocean, just like you need calcium for your bones, they need calcium to build their shells. And the type of calcium they use is calcium carbonates. Don't forget the carbon. So shells, sea coral. Right? The same carbon dioxide in the atmosphere. In the biosphere, we use it. The plants use it during photosynthesis, right? Human beings breathe the oxygen that is part of the photosynthesis, right? And then in the hydrosphere, in the oceans, this is what happens, right? So these animals use it to form shells. And when they die, when those animals die, their shells pile up at the bottom of the ocean, right? They keep piling up. When these animals, crabs, mollusks, all of those aphids that have shells, once they die, they fall to the bottom of the oceans. And over millions of years, those shells pile up and form what is called limestone at the bottom of the ocean. Limestone. Right? Limestone. From dead animals, the shells of dead animals. Okay? Let me play you guys a quick movie on carbon. Let's examine again what happens to carbon. I've only spoken about photosynthesis, cellular respiration, right? And I've also spoken about consumption. Is basically you eat plants, you eat plant tissues, and you absorb the carbon in the plant tissues.
Looking at you when I'm sleeping.
Right?
Oh.
Okay? So I've spoken about the first two processes here. Photosynthesis, that's number one. Cellular respiration is number two. Consumption. What is consumption? That word consumption means to eat. And if you remember the food web, this pyramid right here, right? At the base is the plants. The plants get eaten by herbivores, right? Small animals like the rabbits and caterpillars and the rest of them. Those get eaten by birds or other small animals. Those animals get eaten by other bigger animals. All that is happening is carbon from the plant goes into the animal. And that animal is the next animal, that carbon keeps getting transferred. Okay? Through consumption. Okay, so how do human beings acquire carbon? Sometimes through consumption. A lot of times through consumption. How do they get carbon? By eating plants and other animals. Okay? That's how they go from organic carbon gets consumed from plants to animals. Decomposition, what happens? When plants die or animals die, they fall to the ground, and then some bacteria in the ground break them down. Right? Those bacteria, they break them down into organic carbon. That process of being broken down is what's called decomposition, like decomposers. We learned about decomposers on the food web, at the bottom of the food web. Everything eventually comes to decomposers. Bacteria and fungi in the soil that breaks down plant and animal tissue into organic carbon.
Hey, can I move?
Right? Decomposition.
Just like this to goofy. I move.
Right?
Nigga can't sleep.
And then combustion, burning.
Corn. Socket.
Burning. We spoke about fossil in the ground, right? That's the form of carbon in the ground. And when you burn those fossils, that carbon is turned back into CO2, into carbon dioxide. If you burn fossil fuels like the gas, all of that, or you burn oil, that's smoke, that's carbon. Okay? So some of these key processes you guys gotta know. What is combustion? Decomposition. Consumption. What happens? Photosynthesis. Respiration. Okay. Watch a movie real quick. You guys will see some of the same concepts being explained in the movie. What's wrong with you? What's wrong with you?
He throwing me off about the sauce.
It's right there.
He
Build a website you love with Wix.
I'm a carbon-based life form. You're a carbon-based life form. We eat carbon, exhale carbon. Our homes, transportation, and economies are built on carbon. We need carbon, but maybe too much. How does carbon flow in and out of wherever it's currently leaking out? We'll find out together in this episode, all about the carbon cycle. Most of Earth's carbon, about 65,500 billion metric tons, is stored in the geosphere, inside rocks. The rest is in the ocean, atmosphere, plants, soil, and fossil fuels. These storage containers, if you will, are called reservoirs.
You guys just said the word reservoirs, right? Where carbon is stored. Note that.
Carbon flows between each reservoir in an exchange called the carbon cycle, which has fast and slow components. It is important to note that any change in the cycle that shifts carbon out of one reservoir puts more carbon in the other reservoirs. It has to go somewhere. Through a bunch of chemical reactions and tectonic activity, carbon takes between 100 and 200 million years to move between the atmosphere, rocks, soil, and ocean in the slow carbon cycle. The movement of carbon from the atmosphere to the lithosphere begins with rain. Carbon in the atmosphere combines with water to form carbonic acid that falls to the surface of the earth in rain. This acid dissolves rocks in a process called chemical weathering. This process releases things like calcium, magnesium, potassium, and other things that are stored in rocks. The flow of water then washes these ions into rivers, then out to the ocean. In the ocean, the calcium forms calcium carbonate. Shell-building or calcifying organisms, such as corals, sand ballers, sea stars, sea urchin, and plankton, use calcium carbonate to build their outer protective layers and shells. After these organisms die, they sink to the seafloor. Over a long time, layers of shells and sediment are cemented together and turned to rock, storing that carbon in limestone. 80% of carbon-containing rock is made this way. The remaining 20% contain carbon from living things, or organic carbon, that have been trapped in layers of mud. Heat and pressure press down and compress the mud and carbon over millions of years, forming sedimentary rock. When dead organic matter builds up faster than it can decay, layers of organic carbon become things like oil, coal, and natural gas instead. So it makes sense that we call these fossil fuels. The slow cycle returns carbon to the atmosphere through volcanoes. When tectonic plates collide, one sometimes sinks below the other, and the rock it carries melts under the extreme heat and pressure. The heated rock releases carbon dioxide, which is then vented back to the atmosphere when the volcano erupts to begin the cycle again. The time it takes carbon to travel through the fast carbon cycle is measured mostly in a lifespan because it is largely movement through the biosphere. Carbon molecules are an excellent source of fuel for all living things. Plants and phytoplankton are the stars of the fast carbon cycle. Phytoplankton, or microscopic organisms in the ocean, and plants take carbon dioxide from the atmosphere by absorbing it into their cells. Using energy from the sun, both plants and plankton combine carbon dioxide and water to form sugar and oxygen in a process called photosynthesis. Carbon can cycle from a plant back to the atmosphere in one of four ways. Plants break down the sugar to get energy that they need to grow. Some carbon dioxide goes back into the atmosphere. I know. Plants release mostly oxygen back into the atmosphere, but they do release some carbon dioxide as well through respiration. Consumers, all types of animals, and humans eat the plants or plankton and break down that plant sugar to get energy. The carbon is returned through respiration or waste. The plants and plankton tied to plant life, that seasons like winter and spring are measurably different in the concentrations of carbon dioxide in the atmosphere. During the northern hemisphere winter, when few land plants are growing and many are decaying, atmospheric carbon dioxide concentrations rise. Then, during the spring, when plants are thriving and growing again, concentrations drop. It's like the earth is breathing. If you're still here, liking this video, let us know and hit that subscribe button so you never miss an episode. It's left